You must have heard the term solid principles a lot when it comes to low level design. What are solid principles? By definition, solid principles are the first five object oriented design pattern guidelines, right, that help us create maintainable, scalable, and flexible software. But if they are object oriented guidelines, then they should not be very useful for front end, especially in React, especially in functional programming, right? Wrong. We shall soon see how solid principles can help us create clean, maintainable, scalable, and flexible software even in front end. Uh, Before we begin, let's first figure out what the acronym actually is. S stands for single responsibility, O stands for open closed, L stands for Liskov substitution principle, I is for interface segregation, and D is for dependency inversion. Let's look at each of them separately now. Okay, let's start with the first principle, which is single responsibility principle. Now, what is the definition of single responsibility principle? Without looking at what's happening here, the definition is really simple. As the name suggests, each component will do just one thing and one thing well, right? What does that mean? Uh, in a very naive implementation, let's say we have an e-commerce product and a e-commerce website, and that e-commerce website has a product card component, right? Now, in a very naive implementation, we would have a cart state somewhere, and we would have an add to cart function, and on every product card we will pass the add to cart function. So a naive implementation again is to have the product card itself, and all the state, all the functionality, and the render of that card, everything within one component. Now a lot is happening here. We are handling the state, we are handling functionality, and we are also handling the rendering of the card, which is a wrong way to do stuff. What's a better way to do it, right? What the single responsibility principle say is that each component should only do one thing and one thing well, right? So there are three things happening here. One is the render of the product card itself, right? The other is the functionality, and the third is the final UI, which is handling the business logic, right? Let's look at each one of them separately. First, let's look at the product card. Honestly speaking, product card only cares about the product name, maybe description, etc., whatever, right? But it honestly just cares about how does it render it, right? And nothing else. And on click of the add button, it should just call the function on add. How is it implemented? Does it care? Should it care? No, right? The function of product card is simply to plumb the functions on button calls or button clicks, right? And render everything, right? Now there is another hook that we create to actually maintain the cart, that is use cart, where we have a cart state and add to cart function. Now tell me one thing, how is this add to cart being used? Does this use cart hook care, or should it care? No, right? But it has to be called with one parameter, that is the definition. All it cares about is whether it's being called with the correct parameter or not. That is it. So use card function is the functionality, product card component is the rendering, right? Now these are two totally separate functions or components in themselves, right? They do not really care about how each one of them works, and hence they should not be a part of a single component. They can be created separately. Now the final function or the final component, which is shop here, this is the place where business logic lies. What it does is it has a use cart function. Sorry, it calls the use cart hook, gets the cart from there and gets the add to cart from there, right? Uh, Now in this example, we are not doing anything with the cart state, but essentially, if we had a product cart as well here, the cart would be passed there, right? That product cart will be created with something like this, and the functionality, whatever we have from use cart, right, that is being passed to product card in essence, you see, on add. Now again, how does this add to cart work? The product card does not really care. All it cares about is it should work, and how is any function consuming add to cart Using that function, this use cart hook does not care about that. All it cares about is whether that usage follows this definition or not. So this is single responsibility principles. Essentially, each and every component should just do one thing and one thing very well. That is what single responsibility principle is. Coming to the second principle of solid, which is O, which stands for open close principle. What open close principle is? It's very simple. Don't look at this definition. This is just difficult to understand. The simplest definition is closed for modification and open for extension. What it means is any component that you design, by definition, it should be open for any extensions, right? But it, once the type of or interface of that component is designed, it should be closed for any modifications. For example, let's say we have a button in our design system, right? That button takes children here, and it has an on click and some variant, right? Based on some variant, it will have some styles. Let's not care about these styles, okay? But let's say we also need a loading button. Now that loading button can or cannot load based on the prop that is being passed. Now here's a question: what would you do here given a choice? Would you keep on rewriting this every time whenever you need a loading button, basically this whole thing, or would you just create a loading button, right? Essentially, the first thing that we learn in React is that there has to be reusability, because everything is a component, right? So you would create this loading button component, right? What are we doing there? We are just extending that button with a new behavior, right? With a new state, with a new interface, right? So what are we doing here? We are what is happening here is this button is open for extension, but did we modify this actual button? No, it's closed for modification. That is what the open close principle is in simplest of terms. Okay, the third principle now, which is Liskov's substitution principle. What that is? Now this definition is a bit difficult to understand. If you want, you can just pause the video and try to understand it. But essentially what this means is, let's say we have two kinds of components. One is the base component and one is a derived component, or a component which extends the base component somehow. As we can see, that admin button extends button component, right? And adds functionality to that button component. If we have two such components, and if the Liskov substitution principle says that both of these components we should be able to use them interchangeably, as in, if I pass an on click and use either of these buttons somewhere in the UI, both of them should work all the time, because the definition of a button is it should do what it's supposed to do on click, right? Now what's happening here is, in this example, the admin button looks at the user role, right? And if the user role is admin, only then it passes the on click to this button component, right? Which is wrong, because for any other user role, let's say we have a guest or a member user role or some other user role, right? The on click will be undefined here, which is not the contract. On click should always, oh sorry, on click could never be undefined here, right? You see, and hence, if let's say somewhere I'm already using a button, and if I replace it with admin button, this might not work always, right? And second thing here, it is also breaking the single responsibility principle. Why? Because it is caring about, and a button is caring about something other than what's not a button, right? It should not care. It should not care about what role is this, or what access control does this user have, right? Okay, moving on. What's a better example of, or what's something that follows Liskov substitution principle? It's simple. In the open close principle, we saw the two types of button. One is button and the other one is loading button. Ideally it should be extending. Cool. What is happening here is, let's say I want to use somewhere in the UI a button component, right? It should work as expected. The label is save, it should show save, and handle click should just work. But Tomorrow, if I want to replace that button component with the loading button component, right, and just pass as loading false, right, will it behave the same? Absolutely, 100% it will behave the same, because we are seeing that if the loading is false, it will just return the label again, which is the same thing here, right? Essentially, loading button adds logic, but it does not break the expected contract. And that is what Liskov substitution principle is. It's very simple. What it says is, if you have a component and if you have a derived component of it, and if you are using the parent component somewhere, tomorrow, if you replace that usage of the parent component with the derived component, the functionality should not break. That is what the Liskov substitution principle is. Okay, coming to the fourth principle, that is I, which stands for interface segregation principle. This is the simplest of the bunch, right? Don't force components to accept unnecessary props. What this means is very simple. Break down your components into smaller, focused, logical components. For example, let's say we have a user dashboard and the dashboard has many charts, right? Now, there could be multiple kind of charts. Some charts could have annotations. Some charts are simple enough that they don't need any gimmicks at all. Some charts will need to be zoomable, and on zoom it should show extra functionality. Now my question to you is very simple. Would you create a really big chart component that handles everything? No, right? What will you do is we'll create interactive chart components. We'll create different chart components. Let's say one could be interactive chart component which requires on hover or on click. The other one could be a zoomable chart which requires on zoom. There could be a third one, a simple chart which does not require any functionality, right? In that case, we'll just pass the data prop there. So essentially, the base chart of all of these could be same, right? Which has no functionality at all, right? Following the open close principle, where open for extension, close for modification, right? Now, what we are doing essentially here is we are segregating the interfaces as to when what is required. There could be hundreds or thousands of functions being passed to a chart component, but will we create a single component for that? No. We will try to create smaller, more focused components, and each one of it will have its own interface. Could have multiple different requirements. Some of these could have similar requirements as well. Essentially, what we are doing is we are creating small components with focused requirements or focused interfaces, and not passing everything into a single component. That is what interface segregation is. Nothing fancy at all. As you can see here, right, the data is common between both of them. So the interface is really simple. The base interface of a chart will always have data, right? The extended interface for an interactive chart will have on hover, on click, and the extended interface for zoomable chart will have on zoom. That's pretty much it. That is what interface segregation is. Basically, do not pass all the props to a single component where it might not even use most of them. Create separate components and separate interfaces. That is it. Last but not the least, D, which stands for dependency inversion principle, right? What is dependency inversion? Dependency inversion by definition is high level components should not depend on low level details, right? Basically, what this component is saying is that if there is a high level component, right, in this case this component, right, which is creating a user list by fetching this API, right, what dependency inversion says is that this user list or this state should not depend on this fetch or should not care about what this is. Okay, now this is difficult to understand. Think about this. What's happening here is we have a user list. A user list is being fetched. Now, of course, this is not following single responsibility principle as well right now, but let's forget about that. And this is to calling a fetch API call, and this is rendering the data as well. What's happening in this component is it is tightly coupled, right? Let's say if I wanted to test just this component, right? Just using single responsibility principle, I'll be able to test it. But if I want to test the whole user list component, I'll also have to make sure that I somehow mock the API, right? Now that is very difficult, right? Or it could be the case that there could be many services, depending on or there could be many places from where I can fetch the user data. Now the problem here is I have to somehow set up those places, right? Or I have to somehow dynamically update where this data is being fetched from. How do I do that, right? Because right now it is tightly coupled with this fetch API call, right? What if I want to tomorrow change the fetch call, right? How do we do that? The answer is real simple. Honestly, it is really simple, but you have to understand what's going on. Let's say I want to create two APIs. One is a real API and one is a mock API for testing purposes, right? So the low level implementation here is very simple. A real API has a get users function. That function calls the fetch API, right? Another one, that is mock API, has the get user function, but that mock API just does a promise.resolve, nothing else, right? Now what we can do is we can create a context, right? And we can create a environment variable which tells us whether it's a test env or not. Now what we can do is on user list component, we can add a provider on top of it, and the value of that provider will be either the real API or the mock API, depending on the environment that we are in. Inside the user list component, once we reach here, what we do is we just call the use context, pass in the API context, and then what we do is api.get users, and then set users. That's it. Now here's the difference, right? Here the dependency of fetch, right, it was tightly coupled to this component. Here it's not. The user list component does not really care about how the API is implemented or what in dependencies is it using in runtime. All of that is decided by this logic, which is totally outside the user list component, and that is it. App logic depends on the abstract API, which is this, right? The context, and it does not depend on any fetch or any Axios calls or any other logic anywhere else. This is what dependency inversion is. Dependency inversion is again very simple. High level components should not depend on low level details. This is a low level detail. My high level component here, that is the user list, is not dependent on how it does the get users. It only cares about that it does the get users. That's it, right? That is what the dependency inversion is. That's pretty much the end of solid principles. Do let me know whether you liked this video. Like, share, subscribe, and let me know what other videos you want me to create later on. Thank you so much.